I'm on the API services team, and I'll be talking about how the USA Today Network delivers meaningful, relevant content to its readers. Our agenda for today will go through a little bit of an introduction for what the USA Today Network is. We'll talk about where the readers are, and then I'm going to dive into some of our interesting topics where we talk about my topics, news near me, content backfill. Those are some of the ways we're meeting our users and targeting content towards them. We'll go into what our distributed platform looks like. There's some lessons learned in some of these exercises. And then we'll talk about our evolution for our API services and where we're headed next. And then hopefully we'll have some time for questions at the end. Now, I'm not going to go through each brand, obviously, but I kind of wanted to demonstrate the breadth of brands that the USA Today Network covers. Our flagship brand, obviously, is USA Today, but this is kind of a representation of where all we are. On a map, we're just about everywhere in the United States. We have coverage in 34 states where we have at least one or more newspapers. We're headquartered in Tyson's Corner in Virginia. So where are our readers, right? I mean, we are everywhere, but our readers are in even more places than where we are. They come to us from AMP, they come to us from Apple News, they come to us from Facebook, RSS feeds, they come to us from content partners, they come to us from our own native apps, they come to us from our websites, our mobile websites, they come to us from Google search engines, Bing, wherever, you name it, we have traffic coming from those sources, right? So we kind of have to meet the readers where they are. And in this day and age, our reader can be anywhere. So we have to make sure we are wherever the reader is. In terms of, I talked about where we are, where the readers are. You kind of put those two things together. We're surfacing about 1 billion monthly views. We have 3,000 journalists within the network that are creating content for us. And of all of those views and journalists, less than 1% of our users actually come in and use active search. Now, what do I mean by active search? Active search for us is when a user comes to our site, types in a keyword or something, and hits search. It's a little magnifying glass, top right corner. And that's actually a very, very tiny use case for us. But 75% of those views and journalist pages that are created are powered by some form of passive search, where we are surfacing content powered by Solr to the person on that page. All right? We'll go into a little bit of into more specifics of where that happens, but whether knowingly or unknowingly, our consumers are getting content fed by Solr in some capacity. Right? 100% of the authors that create content within our CMS are using Solr, again, active or passive, to find other content being written in the network. They're using it to find multimedia to attach to the stories. They're using it to discover what other journalists are doing within the network, right? How they can relate stories together. All of this is driven by our search engine. And then in addition to that, I talked a little bit about distributed platform in the introduction, where we're receiving about 25 million syndication requests every month. And that's just to get the content from us. Beyond that, those partners are surfacing the content within their platforms, and there's n number of views beyond that the content gets, right? We typically rank in the top 3 for news and information, and our reach is basically 50% of the US digital population. So diving right in, My Topics is a feature we recently launched. This was one of our first forays into personalizing content for our users. This isn't like traditional personalization where we're profiling you and then we target content towards your profile or other users like you and such. This is true where the user is giving us the indicators that these are the topics I'm interested in. Right? As they're browsing the app, we'll give them little pointers to follow a topic. And we kind of build their history on what topics the user is interested in. And when they do that, they then also have the option to subscribe to notifications. So they want to be actively alerted when content in those topics is published. Or if they want to, or if they want to see a customized headline feed, right? Which is simply, here's a summary of all the things that have happened in your topic. So they can sit back, relax, read their feed at their leisure, or they want to be on top of their topic all the time. Both options are available to them. Since we launched, this was only a few months ago, we've already seen about an 8% uptick in our page views just from that feature alone, right? And 8% across that scale, it's a pretty good return for some Solr queries, for some push alerts, and a custom feed for the user. Jason Jadlitsky, VP of Product Management for us, this was a quote that I really liked about him. He said that in an interview with MediaPost, which is, this is just one of the first ways we're making personalized consumer experiences a priority. Right? I talked about our consumers being everywhere. We want to meet our consumers where they are. And we want to make sure that they have the best experience possible when consuming our news, when consuming our content. Be it a niche vertical, be it a hot breaking story, or anything in between. Right? We want to make sure that they are the priority and that they have a good experience using our services. Something else we did along those similar lines for personalization is News Near Me. Now, News Near Me sounds pretty obvious. It'll cater to news that's closest to you for things that are happening near you. However, it's not a news physically where you are, right? We do this detection for which market are you closest to for us, right? Which community of ours are you in? And if you're in one of our communities, we are happy to tell you what's happening in that community, right? If you're in that community, you're probably interested in the things that are happening there. So that's how we're handling News Near Me. It's also allowing us to surface local content to a national audience. A lot of our consumers, they travel, they go to places, and it helps bring that local content up to a national audience. This is surfaced through our USA Today app, and kind of goes with Gannett's mantra where local is national, right? Even though it's in our flagship national product, when you see that local content, you might be interested to learn more and dive deeper into the subject. We've actually seen a significant uptick in local markets app installs as a result of them getting surfaced through this feature. Right, so we're using USA Today to promote local content, kind of cross-promote both local and national content, kind of give our users both a holistic view of here's what's happening at the big picture, but at your local level, here's the things that are going on with you. Content backfill. This is not a new thing for us. We've been doing content backfill for many years. And content backfill definitions may vary. For us, content backfill is how the human and the machine figure out what to put on a page. All right. Before I get into the types of backfill, I want to get some vernacular out of the way. When a human decides to place something at a specific position, like in this slot, right? Imagine our page had 3 slots. A human puts something on slot 2, 1 and 3 are open. So that act of putting something in slot 2 is called curation. They curated a story or a video to that page. And then 1 and 3 are the backfill spots. 1 and 3 are eligible for the machine to fill in. 2 will be untouched by the machine. And the rendered result, if you look, my test data just happened to have 2 of the same motorcycle thumbnails. but this was untouched, and then 1 and 3 got filled in by the machine. So the types of backfill. Currently we have 4 types. Excuse me. We have 4 types of backfill. I'll kind of go into each one in a little bit more detail. So chronological, self-explanatory. It's content sorted by time. It's been our historical solution. This is back from when we didn't even have a search engine. We used to do SQL queries. Content would be, select blah, blah, blah from table where blah, 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 and order by some date. When we introduced Solr, we replaced the SQL query with a chronological solution from Solr. Each module on the page then has additional type filters. So if you look at, say, usatoday.com's homepage, you'll see the main page is broken out into many different sections. Each section could have different filters on it that say, only allow videos, or only allow press releases, or don't allow this type of content, only include content from these sources and of these types. So as the author publishes that page layout, the machine smartly determines which content to discover, which content is eligible for which spots, figures out the curated spots and kind of skips over those, fills in the gaps. And then the other thing it does is it makes sure that no 2 pieces of content or no 2 sections get the same piece of content. If there's overlapping filters, it also has to go through and determine and make sure that if I put a story about topic X in module A, even though module B has a compatible filter and that same story is eligible, I'm going to take the next one that's eligible because I've already used up that story. And all of that happens within seconds of the user publishing the layout and it being available on the site. Published behaviors, that's an interesting problem we had to solve. For us, published behaviors fall into 3 categories when a journalist is editing a story or creating a story. It's called a major update, a regular update, or a quiet publish. A major update is either the first publish of the story or the content of the story has changed in a significant enough manner where the journalist feels it is important enough to have that story float all the way back to the top of the well, or of the module or section, wherever that story will be. So the major update will update all the associated dates for that piece of content. The regular publish which is like a story modification, when there's a correction or a minor update or a thumbnail was missed and corrected. Those types of things will just go through as a regular publish where it doesn't necessarily float the story to the top, but when somebody is viewing the story, they will see that the timestamp for that story changed. So it's our way of indicating to the user that there have been corrections and updates to the story, but the journalist didn't think that it was relevant enough to make it float all the way to the top. And then the last one is a quiet publish. Now, quiet publish is an interesting one where it's more of an administrative action where when, say, a related piece of metadata to the story is affected, get a takedown notice for an image, or a content entity that's associated with a story is suddenly deemed ineligible by our taxonomy team, they will go ahead and delete the entity and perhaps have a replacement entity or something. And that act of deletion could affect thousands to tens of thousands of stories if it was a popular enough entity. When that happens, what the taxonomy team will do is they will go modify all the affected stories with whatever tag modification they need to do, and then quiet publish that content. When this related metadata changes, it doesn't necessarily change what the story's intent was, and we don't necessarily want all of that churn to float all the way to the back of or to the top of the content queue. So in those cases, we will issue a quiet publish, which will reflect the changes on our site, which will reflect the changes to all our customers and whatnot, but it will not affect our backfill algorithms. So chronological worked well for a long time, but now we started collecting signals. And we were like, oh, hey, we have signals. We know some things about page views, and we know things about people sharing stuff. So let's use that data. And the first use case that came to mind was popularity. So somebody said, wouldn't it be cool if we could just do backfill with popular content? So we tried that. But the downside of a popularity-based backfill is, one, your dates become irrelevant. Two, you have to time box it. So what do I mean by time boxing it? When you're doing that popularity query, you can't just say, give me results from Solr ordered by popularity, right? You're going to get the most popular thing in your corpus every single time. So you have to give it a window of, give me the most popular thing in the last 3 days, the last week, last month, whatever your threshold is. However, keep in mind, we're dealing with 109 different markets that produce content at very different rates. So there's no one algorithm or one window that would fit them all. Because if they don't produce enough content for that window, then suddenly we don't have enough backfill. If they produce too much content, we're kind of excluding some of that stuff. So we tried it out. We tried customizing it a little bit. We experimented. It didn't really yield the results we wanted. Also, the straightforward popularity sort also ignores our published behaviors completely, because we're straight up sorting by a popularity number. So we needed kind of a happy medium between the two. And that's where we came up with our trending algorithm. What we really wanted was sort of this tug of war between page views and the age of the content. And it took a long time to kind of arrive I just depict it as a picture, but to arrive to this type of algorithm. And some of the inspiration actually came from a Solr talk I saw, I think it was last year or the year before, where they were mentioning that you could use the same reciprocal function you use for age decay, but for some other numeric value, and treat it like a date. So that kind of got the wheels spinning a little bit. And so we took the age decay function, which just about everybody who uses Solr is probably familiar with. You take the age decay function. We took our page view value and treated it like a date, right? What the age decay thing does is it takes the difference between now and some date field and puts it on a bell curve of sorts. So we did the same thing with page views. We gave it a different decay threshold, and we multiplied the results of the two together. And that gave us this tug-of-war type of concept. It took a lot of experimentation to figure out the bell curves to make sure that it's a relatively even balance, maybe a bit skewed towards the date, more so than the views. But we struck that balance, and we were very happy with it. So what it's maybe hard to see on the screen is a 3D render of the last 10,000 pieces of content published. And if you'll notice, as our content started getting older, even something needed really high page views to start approaching the higher scores, right? And then newer content with higher page views will obviously always float to the top. So that was our happy medium between the two. We get the best of our published behaviors, because now when the dates change, it affects the relevancy in backfill. And when something suddenly gets very popular, that also affects relevancy in backfill. That's for content backfill. When we took a stab at direct personalization, we looked at collaborative filtering. But at our scale and our use cases, that's a very, very hard problem to solve. Our news is very temporal, right? The shelf life of some stories is few hours at best. Because of the plethora of sources that our users come from, a lot of our users are one and dones, i.e. they'll come, they'll read the story that they came here to see, and then they'll leave. So it's very hard to model, create a model off of that user. So we've, for the time being, we've deemed the collaborative filtering problem as a hard problem to solve. Our data platform team is researching some solutions on how to address that issue and how to simplify the problem for us so we can effectively solve it and actually get a return on it. That's something maybe we'll save for a future talk, maybe next year or something like that. Which brings us to our distributed platform. We talked about all those algorithms and such that backfill things. We talked about we're on platform within our apps, within our sites, within our mobile sites. Distributed platform is sending this content out to the world, off our platform. Where do we go? We go to AMP, we go to Apple News, we go to FBF, Facebook Instant Articles, we have RSS feeds, and then we have other partners who pull content from us. I highlighted push versus pull because some of these distributed platform partners support a push method where when a journalist publishes some story, we have the ability to send it to them in real time. So that way, when somebody says, blah, 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 breaking news happened, it is available on Apple News at just about the same time it is available on our site. There's no latency or delay or anything like that there. The off-platform ones are more the partners who don't have the ability for us to push to them. So they'll poll our feeds at a regular interval. They'll grab whatever has been published since the last time they polled and consume the content that way. So what does that look like? Because we can't just send everything everywhere all the time. Because our content also has rights, evidently. Because our sources of data are numerous, our agreements with every single partner may vary, we have to have a mechanism to make sure the right content goes to the right partner at the right time. And each one of these processes has this rules framework that can tag any story that was published or any content that was published with who is allowed access to it, who is not allowed access to it. And then on the push partners, we make that determination real time as the story is published. And if it's eligible, we'll push it out. If it's not eligible, no harm, no foul, we just keep it back. At the same time, we have a dedicated Solr instance for our distributed platform. It's a time series sharded collection. We keep about 8 or 9 weeks worth of data on there. And each week, the shards rotate, and the oldest shard gets dropped. A new shard is created for the following week. That's to keep a tagged version of the stories in that Solr instance. And when I say tagged version, it's all the story content that would be in our every other Solr instance, but it's also tagged with all the consumers who can read that story and all the consumers who explicitly have a rule to deny that story. Then when our calls come in to poll our content, every call is tagged with who the consumer is. And based on that consumer, it becomes a simple filter on Solr to say, just give me things that this consumer is allowed to see. So on the read side, that makes it highly efficient. But on the write side, we kind of have to do this upfront logic of determining what the sprawl or the impact of the story is. So from that, what are some of our lessons learned? We write our content everywhere as our customers want to read it, which is great, but we have a lot of customers who want to read the data in very different ways all the time. So while that's really, really fast for them on the read side, some of the challenges we have are keeping those views consistent. If we make a change to the meaning of a field in one view, we have to make sure we capture every single view and make sure that we're not breaking any single customer. Related data changes require a large amount of reprocessing. Some of our customers require the data be a little denormalized, which we have done in the past, and we found that when that related piece of data then changes, we have to go through and reprocess all the affected data. And in some cases, it's all the data. Lack of a strict schema made our changes very unpredictable. We were running a Node.js stack, and as long as the upstream system sent some data to our presentation tier, it would basically accept it and transform it and save it. Well, when we changed fields or when we, when we made updates or added new fields, we didn't really know what we would impact from a downstream customer perspective. We had no insight into what they were doing with that data. And some of it stemmed from timelines, but our business logic ended up getting spread across multiple tiers. We had business logic in our CMS, we had business logic in our presentation tiers, we have business logic in our syndication tiers. I talked about denormalization earlier. Well, denormalization is great because all your content is bundled nicely, it's available in one view, but simple data changes, again, require a whole lot of reprocessing. It made our data in the index look different from our data in our persistent storage. So our users were always like, well, I want the headline field from the database, but to filter by it, I have to use a title field in Solr or something, right? The casing could be different. Some is camel case, some is lowercase. So there was all kinds of inconsistencies, and you always had to play this mental map game to figure out who wants what where. We exposed the raw Solr endpoints to our users, albeit with a proxy, but we exposed the raw power of Solr to them, thinking, they can do what they want. Well, in practice, they really didn't care to craft very advanced Solr queries. They would always come to us and say, can you help us put this together? Or they would find a query that some other team had done, copy it, modify it slightly to suit their needs, and then go to town. That led to new use cases going to production without us having any insight into it. That led to query sprawl. We had no idea the types of queries people were doing. We would have to examine access logs to see who was doing what. Well, enter content pipeline, which is our next generation for our content platforms at the USA Today Network. We are planning on writing the data once, single view, single write. Don't have to maintain 8 different transforms for our users. All of our customers will work off of that single model. We are being very stringent on where business logic sits. Our mantra is to provide content as a service, and we are not in the business of maintaining business logic. So we are making sure the teams that own business logic actually put it in their tiers and not offload it to these API teams. We're normalizing our models in both storage and in index. When we had done the initial Solr indexing activities, we had denormalized a lot of the data, thinking our customers will want to be able to boost and query and filter on related data. Well, in practice, that turned out to not be completely true. About 90% of the use cases we analyzed last month turned out to really use only the main elements of the story itself and some elements of related data, but mostly those were by ID. So as long as I have the referential ID for the related piece of content, I'm good, I'm golden. The user can go find that thing, discover the IDs they care about, and then filter in Solr with that. So the benefits from this was related model updates don't require special processing. Those update in their own index at their own time. No harm, no foul. All queries continue to work. We don't have to go back in time, retouch any data. We only retrieve the data we care about. I'll touch on that a little bit in the next bullet, which is enter GraphQL. So because we went to the single model, but we're cognizant of the fact that our customers have different needs for what data they want. Some want everything, some want very little. We're exposing our content through GraphQL. So now our customers have a menu of what data they want. Do they want just the ID, the headline, and the promo image? Or do they want everything? And they can construct their queries as they see fit, as they, whatever works for them. All data access became uniform. So everyone's coming to the same content pipeline. Everyone's using GraphQL. Everyone's consuming the same model. We all speak the same language, right? No one is talking about, for this view, I called it this, but in this view, it's this. Are they the same fields? It's all one field now. We got rid of all of that spread. And then we abstracted, one more. With some instrumentation we did in New Relic, we're actually tracking what GraphQL fields our customers are looking for. So when we make a change to a field, we know we can look at our instrumentation and determine changing the headline to title is going to impact 30 million queries. Well, let's go have a conversation with those customers. Or we're going to look at deprecating this odd field that no one seems to be using. Well, instrumentation can back that up when we go to deprecate that field and say, there are 0 customers for this field. We don't need to maintain it anymore. Then to the point about exposing the raw power of whatever search engine to our user, we abstract that away now. Our users will use GraphQL to search as well. So the technology behind it could be anything. Could be Solr, could be a SQL query, could be whatever. And that way, search becomes another GraphQL query. Everybody, again, speaks the same language. The fields will match. It's a one-to-one correlation. All of that spread confusion is gone. Our new searches will always be reviewed. Because if you're not familiar with GraphQL, if you want to add a new type of query, you have to account for it in your code somehow, right? You have to build the resolver. You have to build the actual plumbing to make the query work. So now we have testing, and we will have actual review processes on the types of queries people want to do. We'll have use case examples. We can push back on something that looks very complex but shouldn't be. And then relevance engineering, as a result, can happen completely independently. We've provided the pipeline when these reviews or these queries are reviewed, they're merged, they're deployed. Well, we just gave them a self-service query builder. And then they can build their application as they see fit to consume those queries. Where are we headed to next from there? We want to build some feedback loops from our distributed platform. What we sometimes don't, or our journalist doesn't know, or even for analytics, is how much of the content that gets produced actually ends up getting rejected by our policies or our rights or our partnerships. So we want to build that feedback loop into our instrumentation that says, story X was published, it went to Apple News but not Facebook, but it went to here, it didn't go here. We want to kind of get some insights into that. We want to solve the search CDN purge problem. I can talk a little bit more about that offline because it's a bigger topic by itself. But basically, search doesn't instant purge well. Search can have a TTL on it, but you don't know what queries affect which searches or what content that's published affects which searches to be able to go purge those caches. So that's something we're actively researching and trying to solve. I talked about this earlier. We want to solve the harder personalization problem. But the steps we've taken in between to kind of get there should give us good indicators on what our users like to do. We want to switch more of our customers to the GraphQL-based content pipeline. We've already started migrations for a lot of our dev teams. Our mobile team is well on their way to adopting the new pipeline, and they're seeing very promising results. And then we want to do faster on-the-fly access management. The rights management I talked about, where we pre-tag the content in the specialized Solr instance, I want to do away with that. That's additional complexity, that's additional operational costs, that's additional things we have to maintain. We want to be able to just do that on the fly for all of our platforms and not have specialized use cases. So we're hiring. If you're interested in any of these things, hit me up. I put a QR code so you don't have to type that link. And thank you. I'll take questions if you have any. I think we have about 5 minutes, so if you have questions, I'm happy to answer. Sure, go ahead.
I'm just curious if you do any dynamic experiments on your content, like trying out like multiple headlines, and see how or sort of lead or whatnot. Because I know other publications do and kind of surface out what works better.
Right.
And how do you fit those type of dynamic experiments? I just for example, I'm just curious if you do anything like that, and how does it fit with your content pipeline or
sure. So there have been some experiments like that. I'm probably not the best person to answer those because those were handled by our data analytics team and such. But from what I understand, they had these A/B models. They targeted specific stories that they wanted to do the A/B headline test on. And they used a third-party framework to do it basically at the edge, not through the content pipeline, yeah. I think if we wanted to do a more formalized structure, we probably will go invest the time and put it into the content pipeline, put it in the CMS, and build it end-to-end. I think he was, yeah.
What was the time frame in which you did all these changes? I mean, it seems like the presentation is pretty great. Like, how long did it take in terms of?
So the My Topics feature was relatively quick. That was relatively quick, meaning a few months of dev time, native apps, all coordination, all that. News Near Me was similar. The content pipeline has been in the works for, I think, well over 9 months now. And we're still not done with all the work on it. But we've started adopting customers so we can start getting that early feedback on what are the gaps, what are we missing. Does that answer your question? Okay.
So you mentioned about the bell curve where you consider the popularity and the age of the job.
Right.
I was interested, how do you arrive at that bell curve?
It's a very difficult task. Some of it initially was qualitative, right? As we were developing the algorithm, we would throw it into this custom thing we had built to just visualize the results. And we would say that doesn't make any sense. And we would always compare it to the chronological one, right? So that was always our side-by-side. And then once we were happy with some qualitative results, we did a few A/B tests on different parameters for the bell curve. To see which ones got us more click-throughs, which ones got us more retention, which ones caused users to read more than one article. And then we kind of narrowed it down and got to it that way. Yeah, it took some time though. It was not quick by any means. Anything else? Yeah.
Yes. Have you considered to implement some technical solutions based on Solr to monetize the content?
To what?
Monetize.
To monetize the content. Well, I mean, in a way, it's our monetization is from subscriptions, is from content partnerships, is from ad revenue. So we're kind of already doing that, not necessarily directly with Solr though. Yeah. All right. Thank you, everyone.